Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session, we are going to discuss about NEET previous questions from the chapter Classification of Elements and Periodicity in Properties. Let us start now. And this question given in NEET 2024, and from this question, so identify the correct answer from the options given below. And they have given here A nitrogen atom, B fluorine molecule, C oxygen molecule, D xenon atom, and we have to match with and this properties of every element. Paramagnetic, most reactive element in group 18, element with the highest ionization enthalpy in group 15, strongest oxidizing agent. Okay, now you see which one is a, and this is the atom, and this belongs to the group 15, and it has the highest ionization energy because this nitrogen has off filled configuration 1s2, 2s2, 2p3. Okay, and this nitrogen atom, the answer matching with the option 3, element with highest ionization energy in group 15, means that A is matching with option 3. Now see here, fluorine molecule. Fluorine molecule is strongest oxidizing agent and most reactive element in group 18, paramagnetic. So it is not belongs to the 18 and it is not paramagnetic. And the option it is matching with fluorine molecule is the strongest oxidizing agent. Why? Because it has more electronegativity. So it can attract the electron from other atoms. So it removes the electron from the other atom. So it acts as a strong oxidizing agent. So here fluorine is matching with the option 4. So here B is matching with the option 4. Here fluorine is strong oxidizing agent. Fluorine is strong oxidizing agent. Now oxygen molecule, so O2 molecule is a paramagnetic in nature. Okay, here option C is matching with option 1, and xenon atom is the 18th group element. It is the most reactive element in that group 18. Okay, here D is matching with the option 2. So now you see A3, B4, C1 and D2. So which option is matching here? Your option A is matching. So your answer A is correct here. Okay, move on to the next question. The correct decreasing order of atomic radii of lithium, beryllium, boron and carbon is. Already you know that across the period what happens? Across the period size decreases and down the group size increases. Now these are the periodic elements. Okay, and these elements present in second period of the element. Now you see here we have lithium, right? So lithium, after lithium which one will come? Beryllium. So next one is boron and carbon. As you know that across the period size decreases, so now you have to arrange in the decreasing order. So you have to put this sign, it represents the decreasing order. Yeah, this is the decreasing order. So here option which one is matching here? Very nice. So it is option B is matching. Okay, across the period what happens? Size decreases. Why it is decreases? Why it is decreases across the period size? Why it is decreases? So these all elements belongs to second period, right? It has two groups, two orbits, lithium first orbit, second orbit. All electrons are joining into the second orbit, right? As the electron number increases in the nucleus, proton number also increases. So then what happens? The nuclear attraction force, the magnitude of nuclear attraction force increases between protons and electrons. As a result, size decreases. Is it clear, everyone? Okay, then move on to the next one. And this question given NEET 24, and arrange the following elements in increasing order of first ionization enthalpy. Okay, already you know that what is ionization energy? The minimum energy required to remove an electron from the last shell of gaseous atom is called as ionization energy. So here we have some exceptions. The atoms which are having fulfilled configuration or off-filled configuration has more ionization energy compared to the next elements. Okay, now you see here we have the lithium, beryllium, boron, carbon. Now you see lithium, is it visible to you? Yes, I use your red pen. So lithium, what is the configuration of the lithium? 1s2, 2s1. Beryllium configuration is 1s2, 2s2. Already you know that this beryllium is off filled configuration. It is fulfilled, sorry, it is fulfilled configuration. Next, carbon electron configuration is 1s2 2s2 2p1, and so carbon atomic number is 6, sorry, so 1s2 2s2 2p2. Nitrogen 1s2 2s2 2p3. Now it is off filled configuration. Okay, so off filled configuration has more ionization energy, so compared to the other element. Now you see, among all these elements, so which one has more ionization energy? Already you know that across the period what happens? Across the period, as you move left to right, what happens? The size will decreases. Means if size decreases, ionization energy increases. We need to use more energy to pull the electron from the last shell. Why? Because the nuclear attraction force increases on the last electron. Okay, now you see, these are the periodic elements: lithium, beryllium, boron. Boron is there? Yes, boron also there. So I forgot to take boron here. So boron number is 5, 1s2 2s2 2p1. Okay, boron. Next one is carbon. Next one is nitrogen. So across the period, size decreases, ionization energy increases. Already you know that. But here, because of off-filled configuration, this beryllium has more ionization energy compared to the boron. Now, now you arrange the order now in order, increasing order. So boron will come here, next beryllium, next carbon, next nitrogen. So because of off-filled configuration, nitrogen has more ionization energy. Okay. Now, as compared with the oxygen, here not given oxygen. So here which one is matching your option? Lithium, boron, beryllium, carbon, and nitrogen. Okay, so you have to select your option B. So which one is right option here? Option B is the right option. Okay, is it clear everyone? So why here beryllium comes after boron? Why? Because the beryllium has fulfilled configuration. Now here the beryllium has fulfilled configuration. So because of this reason, it has more ionization energy compared with the boron than boron. Okay, move on to the next question. Now you see, arrange the following elements in the increasing order of electronegativity. Already you know that. What is electronegativity? Electronegativity means attraction of bond pair electrons in covalent bond. Let us say this is a hydrogen atom and this is a X atom, electronegativity atom. Then because of more attraction power, so it will attract the electron. Which electron? Shade pair electrons towards in its direction, and that is we called as electronegativity. As you move across the period, what happened? As you move across the period, size decreases, attraction forces, means nuclear attraction forces on coming electron increases, or on bonded electron increases. Now you see, across the period, size decreases, electronegativity increases, and down the group, size increases, electronegativity decreases. Now you see the given elements. Now you see which one is having more electronegativity. Let us see now. So oxygen, nitrogen, oxygen, fluorine, carbon, silicon is there. So you arrange all these elements in correct order. So first carbon will come. So what after carbon? So which one will come after carbon? Nitrogen will come. Yes or no? After carbon, nitrogen will come. Next oxygen. Next fluorine. Okay. So where that silicon will come? Silicon in the group of fourth group. So carbon, silicon, germanium, like that it will come. So across the period, what happens? Across the period, size decreases, electronegativity values increases. So which one is having lesser in size compared to all these elements? Fluorine. Okay, then fluorine has more electronegativity than other element. So then oxygen, then nitrogen, and now you see across the down the group, what happens? As the size increases, electronegativity values decreases. Now the silicon has more size compared to the carbon, then this carbon has less electronegativity compared to the remaining elements. So this is your electronegativity order. Now which one is matching your answer? So your answer A is matching. Okay, so your answer A is matching. Is it clear everyone? Across the period, size decreases, you arrange the elements in their atomic number, okay, in groups and periods. So these are the periodic elements. What happens here? Across the period, size decreases, nuclear attraction forces on bonded electron increases, so electronegativity also increases. Okay. Now carbon will, silicon will come under carbon group: carbon, silicon, germanium, tin, lead. So silicon has more atomic size compared to the carbon. Okay, among all these elements, silicon has bigger in size, so it has lesser in electronegativity. That's all. Okay, then move on to the next one. Now, the element expected to form largest ion to achieve the noble nearest to noble gas configuration. Okay, to get the noble gas configuration, so the element expected to form largest ion. So which one will form the largest ion? The atom which will gain more electron, and that one has more ion, that one has more atomic radius or ionic radius. Now you see, to get the noble gas configuration means fluorine, the nearest noble gas to the fluorine is neon. Then fluorine atomic number is how much? 9. Okay, to get the neon electron configuration, it has to absorb one electron. Okay, it has to absorb one electron, and now it form fluoride ion. So the uh, now it is a noble gas configuration. Now it has how many electrons? 10 electrons. It is the nearest to noble gas configuration. Now you see nitrogen. What is the nitrogen atomic number? Already you know that nitrogen atomic number is 7. Okay. So to get the 10 electrons or neon configuration, it has to gain how many electrons? It has to gain 3 electrons, right? After gaining the 3 electrons, and nitrogen will become N3 minus nitride ion. Okay. So it also has 10 electrons and getting the nearest to noble gas configuration, neon configuration. And all these elements are getting neon electron configuration. Now you see here carbon is there, sorry, B is nitrogen and C is the sodium and D is the oxygen. So now you see sodium. Sodium atomic number is 11. To get the nearest noble gas configuration, it has to lose one electron and also it gain one positive ion on sodium atom. Okay. Now after losing one electron from the sodium, the atomic size, the ionic radius of the sodium will decreases, right? So now uh, option D you check, oxygen is there. Oxygen atomic number is 8. To get the 10, it has to gain how many electrons? 2 electrons. It has to gain how many electrons? 2 electrons. After gaining 2 electrons, it will become 2 minus. Now you see all these ions are having nearest to noble gas configuration neon. But in the question they have asked for the element expected to form the largest ion. Which one will form the largest ion? Which one will gain more electrons, and that one will form the largest ion. Okay, so among all these elements, which one is gaining more electrons? Fluorine or nitrogen, sodium or oxygen? So fluorine is gaining only one electron, nitrogen is gaining 3 electrons, and sodium loses one electron, so it will decrease its size. Oxygen gains 2 electrons. Now you see fluorine, nitrogen, oxygen, among these 3 elements, the nitrogen absorbs more electron as compared with the fluorine and the oxygen. Then nitrogen ionic radius is more compared with the remaining elements. Why? Because it gains more electrons. If you gain more electrons, your size will increase. Means atom size will increase. That ionic radius of the atom will increase. Right? Now you see here which one is the right option here? N3 minus is the right answer. So that is nitrogen. So option B is right answer. So this question given in NEET 2023. Okay, so I move on to the next question. Now you see which of the following is correctly matched. Here basic oxides they given, neutral oxides, acidic oxides, amphoteric oxides. Now you see already you know that all metallic oxides are basic in nature. All non-metallic oxides are acidic in nature, and the remaining between non-metal and metal we have one more character is that amphoteric oxides. Okay, they have both characters as well as basic as well as acidic. Now you see this is the potassium. Potassium is a metal, right? So it's a metal oxide means it is a basic oxide. This is correctly matched only. But tin, so tin, where it will come, in which group it will come? Carbon, silicon, germanium, tin, lead. Carbon, silicon, germanium, tin, lead. Okay. Next one is where this indium will come. Indium will come. Boron, aluminium, gallium, indium. Boron, aluminium, gallium, indium. First you are given elements, just you arrange like this, then you came to know which one is actually correctly matched, then we came to know. Already you know that the potassium oxide is a metallic nature, there is no doubt in this. Lithium, sodium, potassium. Potassium is a metallic oxide, that is a basic oxide. But I have doubt about tin oxide and indium oxide. So before going to that, you check another oxides. Okay, carbon monoxide. Carbon monoxide already it is, you know that this is neutral oxide only. This is neutral oxide. But NO2, NO2 is there, N2O is there. So in this, which one is NO2? I think it is acidic oxide, but it is a neutral oxide, and also it is neutral oxide. N2O also neutral oxide, but NO2 is a acidic oxide. Now you see acidic oxide here given. So Mn2O7, as oxygen number increases, acidic character increases. So sulfur dioxide, this is a non-metallic oxide, that is also acidic oxide. Tellurium trioxide also acidic oxide. Okay. Now this is Ga2O3 is there, and this is a gallium germanium oxide, and this is amphoteric oxide only. Beryllium oxide also amphoteric oxide. Boron, aluminium, gallium, indium, thallium. So gallium is a liquid metal, I think. So gallium, this is a metallic oxide. Okay, this is metal oxides. Okay, so metal oxides are basic in nature, except this beryllium germanium oxide. So gallium is a liquid metal, right? So metal oxides are basic in nature. So all this, by observing all these options, we confirm that the acidic oxides are Mn2O7, SO2, tellurium trioxide. Okay, already you know that. So when you come from the left to right across the period, metallic character decreases, non-metallic character increases. Okay, then down the group metallic character increases, non-metallic character decreases. Writing here, metallic oxides form basic oxides, non-metallic oxides form acidic oxides. Okay, in between metallic oxide, non-metallic oxide, we have the dual behavior of oxides, and that will form the amphoteric oxides. Okay, based on this we came to know that. So your acidic oxide is Mn2O7, SO2, tellurium trioxide. Okay, is it clear? Then move on to the next one. Now you see the correct sequence given below containing neutral, acidic, basic, amphoteric oxide respectively. So last one we have amphoteric oxide. Okay, here zinc oxide is a amphoteric oxide. Zinc oxide is amphoteric oxide. So Z and O, here we have the last place, right? And NO already you know that that is the neutral oxide. Next to carbon dioxide. Carbon dioxide is the acidic oxide. Non-metallic oxides all are acidic oxide. Next already you know that calcium oxide is a metallic oxide and it is a basic oxide. So which one is the right option here? So your option D is right option. Okay. Then move on to the next question. The correct order of first ionization enthalpy for the given four elements is first ionization enthalpy. What is ionization enthalpy? Already we discussed. The minimum energy required to remove an electron from the last shell of gaseous atom is called as ionization energy. And the given elements all are the correct order of first ionization enthalpy for the given four elements is, already we discussed what is ionization energy. Ionization energy means the minimum energy required to remove an electron from the last shell of gaseous atom is called as ionization energy. Now you see these are the elements: carbon, nitrogen, oxygen, fluorine. Okay, so while consider the ionization energy, you have to consider which one is having the off field configuration, which one is having the full field configuration. Okay, so but here nitrogen has off field configuration. So the last valence electron configuration of nitrogen is 2s2 2p3. Carbon is 2s2 2p2, and oxygen is 2s2 2p4, and this is 2s2 2p5. Okay, but which one is having the off electron configuration? Nitrogen. Okay, this is a p subshell, it has 3 electrons. This is off field configuration, has more ionization energy compared to the next element. Okay, then nitrogen will come here. Okay, now you see Next, after carbon, oxygen will come. After oxygen, nitrogen will come. After nitrogen, fluorine will come. So the right option is CONF. The option here D is matching. So which one is the right option? Answer D is the right answer. Is it clear, everyone? Okay, move on to the next one. From the following pairs of ions, which one is not an isoelectronic pair? Okay, isoelectronic pair means the elements which are having the same number of electrons are called as isoelectronic species. Now you see in this, which one is isoelectronic species? Oxygen, O2 minus, means oxygen atomic number is 8. After gaining 2 electrons, it will get the charge 2 minus, means it has how many electrons? 8 plus 2 is 10 electrons. Fluorine, F minus, fluorine atomic number is fluorine atomic number is 9. It gains 1 electron. Okay, how do you know that it gains 1 electron? It has only one negative charge. So it gains 1 electron. 9 plus 1 equal to 10. So these two are isoelectronic species. Okay, but which is not, they have asked for which is not the isoelectronic species. So this is isoelectronic species. And Na plus already you know that sodium atomic number is, what is that? 11. After losing 1 electron from the sodium, so it will get 10 electrons. And magnesium lost 2 electrons, so magnesium atomic number is 12. It lost 2 electrons, so and both also having 10 electrons. This is also isoelectronic. Okay, then Mn plus 2 and Fe plus 3 you check here. Mn plus 2 and Fe plus 3. So manganese atomic number already you know that is 25. Manganese atomic number is 25. So manganese plus 2 is there. Manganese plus 2 means 25 minus 2. How much? 23. Plus 2 means, so loss of electron. Okay, so it lost 2 electrons. So 25 minus 2 is how much? 23. So now you check iron. So iron plus 3. So iron plus 3 is, iron is 26. After losing 3 electron, the electron number become 23. And this is also having 23 number of electrons. Both are having 23. So these are also isoelectronic species. The last one, that is Fe plus 2, Mn plus 2. Let us see now. Fe plus 2. Fe plus 2 means 26 is atomic number of iron. Plus 2 means you have to remove 2 electrons from this. 26 minus 2 is how much? 24. Okay, so the next one is manganese plus 2. Already we discuss here. So manganese atomic number is 25. So after losing 2 electrons, the electron numbers become 23. So these two ions are not having same number of electrons. Now you see, iron plus 2 is having 24 and manganese plus 2 is having 23 electrons. So in the question they have asked for which of the following pair is not an isoelectronic pair. So Fe plus 2 and Mn plus 2 is our answer. Is it clear, everyone? Okay, and move on to the next question. Match the following. Here oxide, they given here carbon monoxide, barium oxide, aluminum oxide, Cl2O7, and the nature of the oxides given here. So we have to correctly match it. Already you know that carbon monoxide is neutral oxide. Okay, so here A is matching with 2. Okay, so next one is barium oxide. Barium oxide is, yeah, that is metallic oxide. Barium is a metallic oxide. So where it will come? Beryllium, magnesium, calcium, strontium, barium. In the down the group, metallic nature increases. So barium oxide is a metallic oxide. So metallic oxides are basic in nature. So barium oxide is basic in nature. So this option B here matching with 1. Okay, so A with 2, B with 1. A with 2, B with 1. So already we decided that this is option A is matching here. Okay, so now you see that the remaining also Al2O3. Al2O3 is a amphoteric oxide. It can react with acids as well as bases. Already you learned in 10th class also. And Cl2O7, and remember, if compound with more number of oxygens behaves as acidic oxide. Okay, and Cl2O7 is the acidic oxide. Okay, Al2O3 amphoteric oxide, C with option 4, and D with the option here, D with option, yes, acidic oxide, that is 3. Okay, so which one is answer matching here? So here option A is matching.